There we go. Right. Lovely to be here. Very, very excited to be here. Had a great time going around the field days. I've been up in the chopper, which was really exciting. And next, heading to talk a little bit more about myself. But I thought this is a great opportunity to, let's get techie. Let's get talking about the weather, how it works, and what you can do to make better decisions based on the amazing amount of data that we now have out there. So this is all about precise and actionable weather insights. When I get through today, hopefully you'll understand why it rains and why it doesn't rain. Can I get a show of hands? Who needs some rain? Guessing it's all of you. There we go. We'll have a look at the seasonal outlook. We'll look at the next week. We'll also look at some new tech that is now available to help you plan better. We've got a threat toolbox that I essentially like to call, this is all the stuff that could get you today. It's all of the weather things that you need to be aware of that could impact what you need to do. Okay, this is the big thing. This is what I want you to take away. In order to make it rain, you have to have both of these things working together. You could have buckets of moisture, but if you don't have something to turn that into rain, it's not going to do anything. You can have all the low pressure in the world, but if that's not fed by a source of moisture, you're going to get diddly squat. You have to have both of these working together, and I'm going to show you how we get that. Now, the moisture part of the equation, moisture and low pressure. If you look at that map there, the bright reds and pinks, that is the sea surface, and it is showing how warm it is. So that's generally about 26 degrees. Now, that can contain this much moisture, whereas to the south, all those greens and blues, that's around the 13 to 10 degree mark. That contains about this much moisture. So when we have weather systems come up from the south, they bring just a little bit of moisture with them. If you're south of the ranges, I'm talking about the southeastern part of Australia here, if you're to the south, you get a little bit of wet weather with it. But they often get more than we see elsewhere because it is front after front after front that comes through and turns that into decent rain. But it doesn't go anywhere north of the divide. It runs out of steam before it gets there because it doesn't have that moisture. What we need here is a tropical source of moisture. Yes, it's a longer way away. It's all the way up near Darwin. It's off Queensland. It's off Broome. But that source of moisture is what we need to get good rain in through here. Back a couple of years ago, this is what the picture of the oceans looked like. And then when we went into 23 to 24, this is how it turned. So we had those 3 La Nina years. That was when we had all of the blues, the cool blues, out over that box in the Pacific Ocean. That drove the wet weather towards Australia because all of the warm water was off the coast of Queensland. Over on the Indian Ocean side, we had all of that warm water off the coast of Broome, and over in the box that's out in the Indian Ocean, that one was the cool blues. So both of those oceans were working together to push moisture towards us. Moisture part of the equation, tick. Whenever low pressure system moved through, that turned into decent rain. We had a bit of a flip here. Have a look at this box in the Pacific Ocean. That one no longer blue, it turned warm yellows, warm oranges. What that usually does, it's called El Nino, what that does is it pushes all the moisture away from Australia. However, we don't have the blue that is off Queensland to counteract that. So what happened over the past couple of years is we had, yes, an El Nino, but it didn't have the effects that you normally see. It didn't have those drying effects because off Queensland, we still had a source of moisture. Of the Tasman Sea here, look how warmer than average that was. It was incredibly warm, a huge source of moisture. We still had that to fuel our weather systems. So yeah, we're in El Nino, but we didn't feel the drying effects of that. Here we are now. This is today. Out in the Pacific Ocean, surf's up, the blue has come back, that's those cool blues. We have all of that warm water off Queensland, that is going to actively push that moisture towards Australia. We've got all of that warm water still in the Tasman Sea. Over on the Indian Ocean side of things, we've got some cool blues over in that box, but not entirely, and we have lots of warm water for the rest of it. So this indicates that our moisture source, tick, we have got that. Tropical moisture is going to send that in our direction. We now have 7 out of 8 weather models that are suggesting we're going to go into La Nina. We've already seen it developing in that box, And there is just one model there that is the outlier, but if you were to look at this chart a couple of weeks ago, there would have only been 3 of those models that actually crossed that threshold. The rest of them were up here, and there were 2 of them that were firmly neutral right in the middle of that. This outlier has now come down. Interestingly, that's the Weather Bureau's model. The rest of the international ones are already on board. So I've just got 1 to go to get that 8 out of 8. This tells you that not yet, but in the months ahead, we're heading into that La Nina, which actively pushes that tropical moisture towards us. So the Pacific Ocean, it's going to be tick yes for moisture. In terms of the Indian Ocean, this is where we have been, and this is where we're going. We tried to go into a positive Indian Ocean dipole, i.e. the brown zone in this graph here. It sort of got there, it lasted 5 out of the 6 weeks, and then it did it again, it tried to get there. But what that did, even though it didn't really cross the threshold, is it put high pressure over the southeastern part of Australia, and so that means we couldn't get low pressure in through here. High pressures sat week after week after week. They did not budge, and they did not allow us to get that tropical moisture and let those low pressure systems move through and turn it into rain. So because the Indian Ocean was doing that, that encouraged high pressure to be sitting here. This shows us that we're now coming down from that, and most of the modelling suggests not that we're going to go across that threshold, but at least we should have less of that high pressure problem. So that's what we're looking at this map for. This one is particularly from autumn through to spring. That tells us if we're going to get a heap of moisture coming our way, but it also tells us what that pressure is going to do. So there's another tick that we're about to come out of that high pressure problem. Let's have a look at the October to December outlook. This is from the Weather Bureau. It's a couple of days ago. That was their forecasting. Hello, greens. Central and eastern parts of the country, very widespread. Lots of areas there having better odds for above average rain. So what does this mean? It has said, yes, we have got the moisture going on. But what this also says, there's an underlying disclaimer here that you need to say to yourself. This is part 1 of that equation. It's not the second part. This says, yes, we definitely have the moisture to play with, but it's only if we can get low pressure systems to move through are we going to turn that into rain. It's only where those low pressure systems actually travel as to who gets that rain. This indicates that there should be lots of it, but we need those lows to actually move in. All right, latest weather map. Big fat high. Who's sick of those? Me. Who's sick of saying sunny? Me. There's only so many ways you can say clear skies, blue, fine, sunshine. Ugh. All right, what have we had move through? Here's our latest cold front here over the Tasman Sea. There was one very strong one that moved through the southeast on Saturday. If you were anywhere near the southern parts, you would have felt that. We had an incredibly warmer than average August. We didn't get any of these cold outbreaks come through. Why? Because high pressure was sitting generally out to our east, directing heat that formed over the interior straight down into the southeast. So it was above average. Now we had a high pressure system sit south of Perth. That is the perfect positioning to angle the next cold front to be an absolute beast as it comes up and have Antarctic air in behind it. Here we have the next cold front that came through, and we're now taking a break with high pressure. So there was a very severe frost yesterday because that was in the aftermath of that really cold system that came through. No more moisture in the air. If you're in Brisbane, even they went, oh geez, it's chilly. And I'm like, yeah mate, it's 18, calm down. But there was no moisture in there. They didn't have that cloak of warmth anymore because all of that extended right up into Queensland, which meant that we had the severe frost here. This tells us that there is more frost to come because we've got a high that is moving through and moving out to the east. That means we've got calmer winds, i.e. today. We've got our clear skies, i.e. today. There is another frost on the way. As soon as that moves out to the east, the wind will pick up again because the isobars, these lines will squeeze, and then the next cold front will come through. This map, as it stands, you do not like that high pressure. It is blocking that access to tropical moisture. We need the highs to split to be able to actually tap into that and feed these systems. So I'm telling you that these cold fronts that are in behind it, they're going to move across the southeast. They'll bring more frost in behind them, but if you're north of the ranges, they won't be bringing any rain. That's what we're looking at as we go through the next couple of days. So we're in our Tuesday. This is the rain potential from Tuesday through to the end of Sunday. That's from our AI model at Jane's Weather. So that is all of the different weather models together, a consensus of those that has been adapted to local conditions. This shows you that it hits the southeast, it hits the Great Dividing Range, and it dries out as it goes over the other side. So in the next 5 days, we're looking here at pretty much less than a millimetre. We'll have cold front after cold front. They won't be able to tap into that moisture. They're not going to bring anything. You'll get a shower or two here on Thursday. Okay, so that's what we've got here. We get all of the falls here. We get them here. It dries out as it goes across the ranges. It dries out as it goes across the ranges. There's nothing coming in from here. There's nothing coming from here, so it dries out as it goes across. You will notice, though, there's a lot of activity up to the north. That is interesting. It's the first one of these we've seen as we're going into the new season. This is our tropical moisture source in action. Let's have a look. We've got these falls already in through here. Now I will jump this out as the total from today through to, hello wind picking up, through to the end of Thursday. Oh, is anyone else seeing that map and getting really excited? You should be. Now, this is the AI forecast. As I said, it is 4 global models all working together. And so it's not just one of them that has this idea that we're going to get rain. This one, I've had a look into it, and it is not just one, it's not just 2, it's actually all 4 models that are liking this wet weather. What's happening? The high pressure systems are splitting. The tropical moisture that we have to the north is actually able to come down and connect with those low pressure systems as they come across. It's going to happen over in the west of the country on Monday. Look out at the satellite image. Watch all of that cloud developing. Look at the lightning strikes on it. You'll see that and go, hey, the tropics aren't just being in the tropics, they're connecting with what's happening here in the south. And then that is likely to move across. It's not huge at this stage, and this is the average of all of them. So it's not the big one that you might get, it's not the little ones that we might get, but it's 5 to 10 millimetres. It is something. So it's not 50 millimetres, but it is something. And it might mean the start of those highs moving away and actually allowing us to tap into that moisture and turn it into rain. So this is next week, likely to arrive here around the Wednesday, Thursday mark. Now, you'll go to that and go, right, so that's day 9, 10 on the weather models. Yeah, there's very low confidence that far out in when we're looking at weather models because it takes an approximation of what's happening at the globe right now. It takes 6 hours to process all of that data and it spits out an answer. It made assumptions on what it couldn't see. What it got wrong with those assumptions, it's going to get worse and worse and worse and worse as it goes out in time. So that's why we have less confidence the further out you go. And yes, this is days 9 and 10, but the fact that we have all 4 models liking something like this, that's the best we've seen in quite some time. So that's why I'm excited about it. Okay. Here we have the forecast at Jane's Weather. So I've picked Henty, you can see it in the top left corner there. This is my threat toolbox, the things that could get you today. This is going into Wednesday, and I'm just going to pop down here so I can see closer. That's a low of 1. You can see we had 1 there, we've got 4 on Thursday, we've got another 1 on Friday. So that's the high pressure systems moving through, creating those still conditions, and when you're going to see that. And then there is a bit of a break in between. In terms of wet weather, Thursday, 0.1 of a millimetre, that's literally all it is likely to bring. It's nothing. You might get a tiny little bit here during the afternoon when it moves through, but that's it. Here for tomorrow, here's our cold start. And then this is Wednesday, and here's moving up to 21, 22 during the afternoon. There's bright sunshine, and then not quite as cool in the night that follows. So that goes through storms, temperature, wind gusts, spraying conditions, frost risk, and this has detailed hour by hour when you have that risk. Now, if there was a weather station here that was feeding into this data, it would have adapted to these conditions here. And that's what is so great about what we're doing with this AI forecast. If we can see what is happening on that property, we can provide the forecast that has adjusted to those particular conditions. If we move here, I have gone and selected next Tuesday. That's got 1.6 millimetres on it as the average across all of the weather models, and then 11 millimetres next Wednesday. Again, as the average across all the weather models. Some are less, some are more. And this shows you that it starts here, hopefully around Tuesday night, and it continues through. Now that there is our AI forecast. It's the summary of what they're all saying. This here, I have expanded it out. I've gone into our pro mode, and what that shows you is each and every weather model that makes this up, and so you can see all that guidance side by side. You know how you go to this app, and then you go to that website, and then you look at this app, and then you look at that one. This one says this. This one says something completely different. This one has got no idea. This one's doing this. This is all of that work done for you because it's each of that guidance side by side, so you can actually compare and contrast what they're saying. What this shows us is we've got the green and the purple. That's the Euro, i.e. what you get from YR.no, and the GFS, the USA model. They've got both of those starting at the same time and continuing through to Wednesday, but the other two models are missing. This one here, which is the Canadian, that comes in early Thursday, and the Australian, which is the yellow one, that comes in during the day on Thursday. So yes, all four models have it, but they have different ideas on when it's likely to come. So it's great news that all of them are there, but you need to unpack it and see what's happening. So they don't have it at the exact same time yet, which I wouldn't expect this far out. But this means 1, 2, 3, 4, something is coming, which is great. Okay, some examples of what we do. So we've got our super alert, gets sent emailed to you each morning, so you've got an idea of what's happening. This here is wind gusts on the left. It's an example of how you can clearly see colour-coded hour by hour when you've got an issue. And so this one has 102 k's, 103 k's an hour. This isn't today, it's just a great example of what the wind can do, and it shows you when you need to take action. This one here is our spraying forecast. It takes into account delta T, wind speed, temperature inversions, cloud cover, all of that, and it shows you your available windows to get this work done. We have got evapotranspiration, and it shows you how much of that is likely to be, so what you need to do to irrigate each day. And it also has growing degree days. So this is, you can choose 0, 5 or 10 as your base, and you can see what the forecast is as we're going through time. The other parts we've got there, we've got frost and dew, we've got spraying, we've got evapotranspiration, growing degree days, chill hours, weather conducive to pests and diseases, feedlot heat, so accumulated and the daily. We've got livestock heat and cold stress, we've got solar radiation, daylight hours, UV, there's fire danger, and there's even storms, wind, and all of your regular weather information. But what is great about this is it takes the best data, it combines it together, it adapts it to your particular site, and then it shows you what you can do with it. It helps you make those decisions. So it's not just a weather forecast, it's tailored information for what you have to get done. And the best bit about it is, if you go to janesweather.com, you can start a free trial and give us a go. Great. That's it from me today. I would love any questions if you have them. I presume it'll be about next week's rain. Thank you.
I have a quick one to start us off if we're going to warm up with a question. You mentioned having an on-farm weather station at feeding into the Jane's Weather app. Is there particular weather station companies that integrate, or could you share a bit more about that?
Yes, there's been a lot of trial and error. We've probably got about 20 or so different weather station providers that now easily integrate into Jane's Weather. So it's just, you need to tell us what you've got, give us permission, and we take the data and move it in. It's all done in a silo, so your weather data comes into this point, no one else sees it, it's yours, it's your IP, and then it just helps the forecast that comes directly back to you. Another part about it is, by adapting the forecast to that data on this particular site, it improves the accuracy there by a huge amount. But everyone in the vicinity also gets a bit of a bump up because it's another missing piece of the puzzle. It's a piece of data that we didn't know about before this, that we have been able to adapt the forecast for that spot. So it helps everyone in the greater area as well. We have got lots and lots of different providers that we can integrate, as in if you already have that tech on your farm. Another bit is if you're sitting there going, I don't want to spend $5,000 on a weather station, It'd be great if you could, because that's going to last for a long time. It's going to be maintained for you. It'll be installed. Nothing will go wrong with it. But you can also go down to your local hardware and buy a cheaper one, and that works as well. Yes, it won't have the fine capabilities that the other one does. It's not going to measure your soil moisture and all the other stuff, but it's at least an idea of what is happening in this area that helps all of this work to help you guys do what you need to do.
Cool. Do we have any questions from the floor or outside? I was going to say, if not, I'll keep asking.
With the bomb weather stations, I find that they're a long way from, they might be 40 or 50 kilometres away on the other side of the hill, and here they are quoting weather for your area, and quite frankly, it's got no relationship what's really going on with them. Very frustrating.
Yeah, so when you're doing your legal spray requirement to say what the weather was at that time, you're like, that's got nothing to do with my spot. I highly encourage everyone to get a weather station on their property. It uncovers what's happening in this part of the world. Just think about how the terrain changes, and you've got a little just terrain, so mountains first of all, but this area is a paddock. This one has got trees on it. This one has got a creek running through. All of that impacts what the weather does around it. And it's, again, that missing bit of data that helps everyone in the area understand what's happening. The other bit about the Bureau data is we have the Bureau's model in here, so it's the yellow one, which is the Australian model. But the public forecast you get from them, that's based on data from 6 a.m. yesterday morning. So it will differ from what we're showing here because this has been updated this morning. And we update it 14 times a day. So it's each time a new model comes in, you get the new, this is what is most likely to happen. So you don't have to rely on a Bureau station if it's too far away from your property. Get one yourself. Bring the data in and we'll produce a great forecast for you. And the other bit is, this is current information. It's the latest of what you can expect. Yeah.
Jane, hi. I'm an agricultural consultant. We're constantly looking for microclimate information for some of the work that we're doing. Yep. When we're looking at new projects. Is there anything on your site that can help us with determining microclimates?
Yes, we've got, for example, you've got a farm as a base user, and we have a look at what's happening over your farm. Now, you might have one weather station, you could have 4 of them, and so we've kind of got a really good idea of what's happening. That farm could then be a company that has another site over here, and another one in Queensland, and another one in Victoria, and all of that works together, so you're all working off the one piece of guidance, and you don't have this team working to this, and this one working to this, and not meeting in the middle. So this helps sort that out. But we have spray contractors that have maybe 8 or 10 different sites set up, and they know what is happening at those particular places. We've got drone guys that know that they have the alerts come through each morning, and then they can pick and choose where they go and do the work based on who has the right conditions for that to happen. By having your weather station in here, it creates literally a hyper-local climate of what's going on. It's the recording of what's happening so far, but also using that data to work out what's going to happen from here. So, yes.
Yeah, so one could search on the site for data in an area, and if it's in your system or in your network, we could search that?
Yeah, we're getting to the point. So we've got the DPIRD network in WA, we've got QDAF in Queensland, we've got another number of networks coming on. At the moment, if you don't have a weather station, we invite you to have your nearest Bureau station as your source of guidance. But essentially, when you're picking it, we want it to be not like this, as in the nearest Bureau station's 200 k's away. We don't want that to be your only option. So we're getting as many networks into there as we can. And it's just, you can keep your data to yourself. We're never going to encourage you to share it if you don't want to. But if you do want to share it and help the greater good, then we're going to have that as an option as well. So that's in the development pipeline. Yeah. Oh, sorry, back here.
You're saying if you bring a weather station to get better data on your local microclimate of your own property, how long do you need to get readings from that to be able to analyse it?
Excellent question. 80 days. So that is after a lot of trial and error and looking at what everyone is doing overseas and bringing that into here, that is the optimum time. So if we can go back 80 days, then your forecast is adapted to include all of that information. Now, we do actually go back to December 2022, so we've got longer than that, but the 80 days is the minimum till it's good. Now, the other bit is if you have a weather station that has already been there and has been operating for a year or so, we can ingest that information pretty quickly so it learns in a couple of days and you've got a better forecast from that point as soon as we've ingested those 80 days worth.
Jane, thank you. It's just been so informative. I've probably got 3 questions and I don't want to hog everybody's time. First of all, does an automated weather station count from the Bureau to hook into the system?
Yes, if there is one near your property, you're most welcome to use that particular one. But if it's a long way away, we encourage you to get something on your side.
Yeah. So we've already got a weather station, and where we are, we've been measuring the rain since 1889, not me personally, but we find there's a huge difference between the actual weather station when it rains and the actual what I measure out of the rain gauge. And we think it's because of the wind or something like that. So how does that...
How close together are they?
Oh, about 20 metres.
Perfect, good.
Yeah.
It may be just whatever the technology is of that rain gauge. There is a chance that when that shower came through, it was heavier over this particular part. I know they're 20 metres, but there's a slight chance that did have an impact. But the... It might just need a clean out. My one down the farm did recently. I kept on going, Jesus, has someone built a roof over this? Like, it's not going in. Currently, the Scoresby one in southeastern parts of Melbourne, that's definitely got a roof on it. They need to go and have a look at that because there was a whole lot of rain that came through and they still got nothing. So it may just need a bit of a clean out to calibrate against each other.
No, I have a quick futuristic one for you. What is the blue sky? What is the future? What is the next big thing in weather?
If I could get... Remember the Back to the Future movie? Just randomly. And there's, I think it's Back to the Future 2, and he's getting out of the car. They're in the future, in that amazing time of 2015. And he's getting out of the car, and he goes, oh, it's wet. And he goes, oh, it'll stop raining in 2 minutes. And... wouldn't that be amazing if we could do that? Can you imagine if we could do it down to the minute, that far out? Now, the way to do that is to have much more data than we have right now going into these systems. We need to measure not just in Hay, not just in Wagga, not just in Wodonga, where these weather stations actually are, actually Albury Airport, Tumbarumba. Like, that's too far in between. We've got satellites. It's one every 10 minutes. What's happening in the other 9? We've got radars. If you're on the other side of the radar, we can't see what's happening through there. Yes, there's better radar coverage now through outback New South Wales, but we didn't used to have that. If we can get more and more and more observations of what's happening in this world, then we can use that data to be able to make an even better forecast because we know what is happening. We also need the supercomputers to be able to actually crunch through all of that numbers, but let's at least start with the observations.
Thank you so much. It's been amazing. Ladies and gentlemen, please come together and thank Jane Bunn.